Hello everyone. Today I am going to present a topic on operating system services. This topic is very important because an operating system is the backbone of any computer system. It manages hardware, software and user interactions. Let's explore how the OS provides different services to ensure smooth and efficient functioning. Introduction to OS services. An operating system is a system software that manages all hardware and software resources of a computer. It provides various services that helps users, applications and system itself to function properly. For example, when we open an application, save a file or connect to the internet, the OS is working in the background to make these operations possible. These services plays crucial role in system performance and security. Next, types of OS services. OS services can be divided into two major categories. First one is user services, then the system services. User services. These services helps users and applications directly. They include file management, input-output operations, and program execution. System services. These services manage hardware and internal OS functions like memory management, process scheduling, and security. Together, these services helps ensure a seamless computing experiences. Program execution service. One of the most important service of the OS is program execution. When we open an application such as web browser or a video player, the OS loads the program into a memory, starting executing it. The OS also provide multitasking, which allows multiple programs to run at the same time. If a program crashes, the OS safely terminates it to prevent system failure. Without this service, we couldn't be able to use applications effectively. Then, input output operation service. Input output operations are another crucial service. These services manage all input devices like keyboard, mouse, and microphones, as well as output devices like monitors, speakers, printers. When we type on a keyboard, click a mouse, or print a document, the OS handles these requests and ensures smooth execution. It also prevents conflicts when multiple applications try to access the same device. This service allows users to interact with their computers effortlessly. Then file management service. A file system is responsible for storing, organizing and retrieving files. The OS provides a structured way to manage files and directories. It allows operations like creating, reading, writing, deleting and renaming files. The OS also manages file permissions, ensuring only authorized users can access certain files. For example, in Windows, files are stored in NTFS format, while Linux ext4 is commonly used. Without this service, it could be impossible to store or access data efficiently. Then the process management service. The operating system also manages all running processes. Every application we open is a process. The OS ensures every run smoothly. It uses scheduling algorithms like first come first serve, round robin, priority scheduling to decide which process gets CPU time. The OS also allows multi-threading, which means a single application can perform multiple tasks at the same time. For example, when we watch a video, the OS handles both video playback and audio synchronization simultaneously. This is the process management service. Then, memory management service. The memory management ensures efficient use of RAM, random access memory. The operating system allocates and deallocates memory for programs dynamically. It uses paging and segmenting to manage memory efficiently. The segmentation helps memory management effectively. Virtual memory allows the system to use hard disk space as temporary RAM when memory is full. This service prevents system crashes and ensures smooth execution of multiple applications. Then security and protection service. The security is a critical function of any OS. The OS protects system from unauthorized access using user authentication, firewalls, and encryptions. It ensures that process running in the background cannot access sensitive data. Multi-user operating system like Linux, Windows allows different users to have a separate accounts with different access levels. Without this service, our data and privacy would be risked. Then error detection and handling service. No system is perfect and errors can occur anytime. The operating system continuously monitors the system to detect hardware failures, disk errors, or application crashes. When an error is detected, the OS provides error message and attempts recovery. It logs error for troubleshooting and preventing system crashes. For example, when a program stops responding, the Windows provides an option to end a task to close it safely. Additional services of operating system. Apart from the main services, operating system also provides networking services, visualization support, graphical user interface. Networking services. It allows computer to communicate over the internet using protocols like TCP/IP. Visualization support. Operating system like vMalware, Hyper-V allow multiple operating systems to run on a one machine. Graphical user interface. GUI provides an interactive experience with features like icons, menus, and animations. These services make modern computing more powerful and user-friendly. Conclusion. Real world examples of operating system services. Let's look at some real world examples of OS service. Windows OS, Linux OS, Android OS. Windows OS uses Task Manager for process management, NTFS for file storage, and Windows Defender for security. Uses System for processing control, ext4 for file storage, and strong user permission for security. Android operating system uses Dalvik VM for app execution, ZRAM for memory optimization, and SE Linux for security. Every OS implements these services differently based on its purpose and design. Future of operating system services. The future of OS services is evolving with technology, AI integration, cloud-based OS, and quantum computing, enhanced security. AI integration. AI-powered operating systems will optimize system performance and security. Cloud-based OS. More OS will rely on cloud computing for resources and management. Quantum computing. New OS designs will be required to support quantum processors. Enhanced security. Future operating system will focus on zero trust security models to prevent cyber threats. Operating system services will continue to evolve to meet the needs of modern computing. Conclusion. To summarize, the operating system provides essential services like program execution, file management, process scheduling, memory management, security, and error handling. These services ensure smooth, efficient, and secure operations of the computer system. Without operating services, our computer would not function effectively. Understanding these services helps us appropriate the complexity and importance of operating system. That concludes my presentation. Thank you.